So, welcome. Dzień dobry. So, I learned some Polish words. One of them is dzień dobry, and that means hello. And the other one means something we don't want. Deszcz. So, you realize I've been here in the fall and in the spring, because it's always raining. But today was good. So, my name is Mikael, and I've been working with SQL Server for a long time as a trainer, as a consultant. Currently work at SolidQ in Sweden. So, it's a very nice thing of you to let me come here to your country and talk about locking and blocking. I hope you all have seen the sponsors. And if you missed them, you have a new chance tomorrow. And again, I thank you for being here. It's late, but I don't know. If you weren't here, you would have nothing to do before the party. Right? So we're just waiting. And I promise I have people showing me signs when it's time to quit. So I will not be late. Good. What is the problem with locking? Why do we need locking, and how do we find it? How do we fix it? And what do we have for different techniques to discover the locking here? Well, the problem is reading. Not always, but sometimes. Sometimes when you read, you're really in trouble and you are locked or blocking other people. But most of the time, it's when you're writing. It gets slow. And when there are more people in the database, it gets slower, slower, until the database stops. And sometimes it's so bad that we are decided as a victim and must be killed. That is deadlock. And we're not going to talk about that. We're going to talk about the locks that we can fix in other ways. So, I have a demo. A classic lock. Note to self, do not type text in the demo. Yes. So, I'm not typing, I'm just pressing enter. I have a normal tiny transaction, begin transaction. And I select from my table. And you see here, Adventure Works, a ripoff, only a few columns. And I'm updating the product. Yes. And I'm looking, okay, what's the value? Is it 200? Everybody agrees. It's 200. Yes, good. So, it's 200. No? It's 0, yes. No? So, it's locked. We already have a problem. Because now somebody is really annoyed, they're waiting. And I get the question a lot, okay, can we turn off this locking and logging thing? Yes, we can. Because if I update the price of the Porsche to be 20 zloty, how many would buy a Porsche? Yes. And if I accidentally type something that makes it cost 5 million again, do you still want your order to stay in the system? No. I have had one guy say, yeah, I want a Porsche. but most of us, we don't want, not for the normal price. So we have to decide. We have to decide here, okay, is it 200 or is it 0? My transaction is now rolled back, 1, 2, 3. And immediately we can see this value. So that was good. The locking is a good thing. Oh, I just realized I'm going to do this again. So the first is 0, the second is 200, and we have a lock. Right now we have a lock. So when I'm doing this is waiting forever. Oh, note to self number 1. Sorry, I just have to write in the demo. This one, this is obviously locked, right? This is obviously locked. And we can find out that this is locked, like this. Here we have locking information about what is locking things, and away here we have also resource and a lot of context information that connects somehow magically to this query here. So we can find who is responsible for lock, who is doing the things that are bad. But most of the time, we just want to do splock, because this one connects both the ID from requests and the databases and objects that we want to find. So this one is basically a merge or a join of these two tables. You can write them yourself, but for now it's easier to use this procedure. But this requires that, I'm not going to fall down here and die, or I will try not to. So this requires that we find, is it the locking that makes us have the hard time? And we can do it in 2 ways. And I'm going to show you just a quick way of viewing this. I'm going to cancel this again. Okay. 1, 2, 3. So this one, this is a wonderful thing. I use it all the time because I want to know what SQL Server does and doesn't. And it returns 924 different things to wait for. One of them is I'm waiting for waiting. And the other one is I am waiting for being idle. And another is I'm waiting for doing nothing. So Paul Randall, he kind of removed all those unnecessary ones. And he also did some smart, really smart calculations. So I stole this totally off his webpage and included the link on top. So you just go in and search for "Tell me where it hurts, Paul Randall." And then we see, what is my problem? And you see here, I have some kind of preemptive task. That is undocumented, nobody knows why it's there. It's extreme transaction processing, so it is basically in memory processes waiting for nothing. So let's try to do something like this. My SQL Server is, you recognize this, it's rebooting. I have now 0 wait times. Oh wow, I have a lot of wait times, but all the wait times are very, very small. It's waiting for different kind of locks, different kind of IO, because this is a normal startup. And then when I change, Oh, I hope I have kept the connection. Yes. So when I'm doing this, and we're going to do something smart. Look at this clock. It's ticking. And I'm waiting for around 15 seconds. So, I have been waiting for some stupid person to decide 200 or 0 for 15 seconds. And this query says, okay, 15.88 seconds. I was a bit slow. This is 88% of my waiting times. Check. Box number 1. We can continue the session. We don't stop here. Right? Because this is now an issue. Everything with LCK. That means, oh, we have an issue with somebody locking something and somebody can't read something else. So how did we find it? We found it with wait stats. And this is now still increasing the wait stats. And when I run, the wait stats accumulate, they get bigger and bigger and bigger. But it's sadly only when this transaction disappears that they get added to the list. So if you have a transaction that is running for 1 week, it doesn't show in the statistic because it's still active and it doesn't add it during this time. Oh, I must type in the demo again. Sorry. Because it's obvious it's waiting for number 2, right? It's waiting for number 2. But if I'm taking number 1, that is so much better. No, it wasn't. Anybody knows why? Oh, I have so many good suggestions and all of them are wrong. I have table lock, page lock, it's on the same page, and they're all wrong. Because this query live. It's supposed to get the data with a table scan, right? And one of the rows in the table are locked, at least one. So it's reading row number 1, then it's reading row number 2, and is waiting, and it cannot give you back the result set until it has read the table. So we have problems with blocking, that things are blocking even though they are not. Proof. Of course, proof. SP lock. The connection is broken. I'm so happy it is this connection. So I can do like this. SP lock. Did I just type again? Yeah. Okay. So this is the explanation. I'm going to try not to fall down again. So, starting at the table, or by the way, starting at the database. Database 5 has a shared lock for connection 52 and 53. Anybody has tried to write the command drop database, and it takes a long time, and then it says the database is in use. That's how you can tell. So if I remove these on database 5, the shared logs, I can drop the database. And that's a slight problem, because even though every one of you were wrong with the table was locked and the page was locked, I actually know what's going on, because the table is locked. From number 52, the table, select object name, parenthesis, and this one says probably the name of my table, hopefully. This table is locked with an intent exclusive lock. That means that if you try to lock the table, SQL says, no. Somebody below in the hierarchy is locked. Do not take the lock. So, the page, they're on the same page. Uh-oh. Something in this page is locked. Do not try to take a lock. Check or X. Exclusive. This is my lock. This is the writing. So the writing is blocking database 5, file number 1, page 280, slot number 2. Yes, it begins with slot number 0, of course. So this is the second row on this page. Let's just, for fun, see. This is why I have this. No, this is why I have this. And I am not copying things or writing things. I'm copying things. Run a command so we can see things. And database 5, file 1, page 280, and look at it in one of the ways you can look at it. So this. Do you remember what row, which number that was locked? Number 1, the second. Yes. So here is my page. Here is slot 0, not locked. Here is slot 1. This is the locked item. This one is locked. And you see it is ball in Unicode. So this is actually the data. This is the data page that is changed. This is what I'm waiting for. Seems right, correct? And to prove the facts, yes, we have a shared lock on the table. So something in this table is locked with read access. Something in this page is locked with read access. And slot number 2, or slot number 1, position 2, is locked with a shared lock. This is the one I'm looking at. Or, wait. Yes, exactly, wait. I am waiting to read this row. So this is why you're blocked. Anybody learned something from this? Perfect, wonderful. Did you know I'm Swedish, and I think that is kind of sad. No, it's not sad, but you have the same issue. You're Polish. Like when you're an American, I'm an American, and I'm Swedish. No, I'm a Swedenanin. Like be confident. And now you can be confident in telling people, this is why you wait, because somebody else is doing wrong. It's not me. Good. So how can we fix this? Easy. We can fix this by using another table. Of course, we can fix this by writing one table and reading another table, but that wouldn't be fun. So I'm instead using another table. Oh, remember to show the locks. You've seen the locks? Yes. So I'm going to do the same thing, exact same thing, but now we have a lock, like that, and I'm doing the same query, like this. Yeah, same issue, but the thing is here that Paul Randall's weight stats, wrong, sorry. Of course, it's SPLock. Gives us the same thing, but we don't have a page, a physical address where it is exactly right now. We have a key. This is a key in an index that is locked. What does that mean? Well, it means that I'm pasting, not writing. This one, it works. And it's even this good. This one makes no sense because you need to know who is locking what and do a list of, okay, this one is locking this one, and that takes more time and the locks are gone. But just to show you that we can do it. It reads everything except the locked row because I told it. That has to do with the index. Yes? The execution plan for this query is, of course, a clustered index seek. That means it seeks in the index all except the ones we're not doing. It's not doing a scan anymore. And this is basically the same with a non-clustered index. It does the same thing. So, wow, we fixed it. The index fixes everything. You're laughing. But anybody been to PASS Summit? Heard Brent Osar? Or he was here a couple of years ago. And he says, when I see 5 indexes or more on a table, I'm concerned. And do you know why he says 5? Because he has 5 fingers on this hand, and it would feel awkward to say, if I find 7 indexes. It's much more easy to say 5. If he worked chopping wood, it would maybe have been 4 indexes, something. I don't know. Anyway, no, indexing doesn't fix everything. What fixes everything? Transactions. Transactions will fix. You saw I had a transaction. It was kind of slow because I didn't write commit or rollback, but transactions fixes everything. And transactions are ACID. ACID are the 4 important properties of a transaction. And you know what they stand for? No. Or yes, it does. You must check your transactions because they must be compact and they must be one transaction. They must be consistent. They must be saved, and they can never be divided into I am doing this and then I'm asking the user, are you sure you want to continue? And you pop up a message box and let the user decide later, because this is the scenario we saw. And the transactions, they don't fix everything because they fix everything with isolation levels. So how much are things isolated between transactions? And you see in the shared locks, you see in the exclusive locks, right? And the shared locks can appear how many locks as you want within reason and memory management. Exclusive lock is like the Highlander, the movie. There can be only one. It doesn't chop the heads off the shared locks, it just stands them in line. But the problem is also when a shared lock exists. Let's pretend you are a page and I want to change your color of your shirt. Oh, so you were looking. Sorry, I cannot change it. And I saw you were looking. Oh, and now you are looking. I can never change this guy's shirt because everybody is looking all the time. Do you see where I'm going? So I could put an update lock. You've seen those? A black bag. So nobody's looking anymore. And everybody's just waiting for the black bag to go away. That's the update lock. It only gets in place when there's a really rush to read a lot of things. But we still have some issues with locking because we were many people looking and it was really busy, and you can imagine if maybe you and you find the idea, oh, wow, yeah, let's change this guy's shirt. So we are now 3 persons in line for doing the same thing. And everybody else want to look. Isolation level, but there is a solution that makes everybody read right away. What is that? No lock? Read uncommitted? No lock? Yes. So, this is the default. We've seen that, and that is good. That is so good. So, read uncommitted. Reads without honoring locks. I'm not even setting a lock here. And this is a slight problem because the rows are not committed. And I'm going to illustrate this by, I'm sorry, you're in the front row, so you are my database pages right now, rows. So, number 1, 5, 10, 15, 20, 25, 30, and 100, and 200. Okay? You remember your numbers? Yes. So we are now reading. We are reading things. Uncommitted. 1, 5. I'm changing you from 20 to 20, 25 to 26. Shh, don't tell anyone. 15, 20, 25 or 6. Yeah, we don't know. But seriously, we are getting 26. Even though, do you say he can be 26? No. So you are 30, and you're 25 again because he didn't like that. So I just read 26. That was not allowed. That is a problem. Okay, slight problem, a tiny problem, but still. It's a bigger problem because the 26 could be a trigger. Doom. Because you were the number of nails I bought. And now we have one more or less in store. And that's a problem. But the catastrophic thing is this. Imagine there is a clustered index that fixes all problems. We saw that. There is a clustered index, and we are writing no lock. One, 5, 10, 15, 20. Wait, you said 20? Oh. I like to be 17, so this is my spot, right? Good. 25. I'm in the table, but you didn't hear me. I'm in the table. So when I read again, 1, 5, 10, 15, 17. No, I want to be 26. 25. And I'm 26. So how many times did you hear me? 2 times. And I have a unique key, a primary key. So if you read with no lock, if you read with read uncommitted, if by any chance somebody is changing the clustering key when you're reading, you can either lose rows or you can have duplicate primary key reads to your application. And you know what? Your developers say, no, duplicate primary key can never occur. And you show them by writing select star from this table, and you get one row of each. Because the problem is only occurring once in a million when you are more than one user. And in your test environment, you're alone. So I would advise never to use read uncommitted. But this, of course, your problem, it isn't fixed by read committed, because I'm only reading and locking when I ask you. If I didn't ask you, you can change to 26 whenever you want. And you can change to 17. Like, go there, and we would miss you. Really. And that is why we have the repeatable read. That means that we are locking everything that we are reading, so nobody can change. Right? And then the annoying speaker comes in again with number 150. There is a tiny spot there. I would fit. So we can fix that too. Serializable. I'm locking everything. I'm putting a police tape here. And I'm even putting it on the 0, the seat behind you. There is no way somebody can sit there. I'm blocking the entire index, the range, everything. So now there can be only one, but in a bad way. This is serializable. Okay, I'm reading, I'm doing stuff. Nobody else can access this until my transaction is done. So we have this, okay, we're consistent, or we can read everything and it's fast, but not at the same time. Right? We agree? So, I need to ask you a question as well. It's maybe a sensitive question here. Oracle, anyone? You can raise your hand a little. Yeah, some has Oracle. So, when I do this update, what does Oracle say? Does it say 200? Or does it say wait? Or does it say 0? 0, yes. So somehow Oracle manages to get the last value of your transactions, the value that was before the transaction even started. That is cool. So it finds the value and it shows you what it was before this guy started to do begin transaction and even before he started changing something, anything. Wow. Using some kind of version store, yes. And the problem with this version store is this. This is allow snapshot. So I'm rolling back my transaction and I'm setting alter database allow snapshot isolation on. Boom. The server dies. True fact. I'm not using transactions now. I'm not using snapshots now. But I might. And to be sure that I don't miss anything, the SQL server now, from now on, in this database starts to copy everything that is in transactions out to tempdb. Wow. So the tempdb dies, everything gets slow, and we're not even using it. Because right now, it's read committed. The thing is that I can set transaction isolation level snapshot to this one, if I want to. Then it starts to read things from the snapshot. Should we try? Transaction isolation level snapshot. And I'm doing this again. And of course, I'm doing this one. So, what went wrong? I expected this one to actually work. What was wrong? Wonderful. I will fix you some coffee later. Wonderful answer. Yes, I was slightly stupid, right? Because I set the snapshot thing on the transaction that is writing. But I need to tell this one that you are reading from the snapshot. So I'm stopping it, I'm setting it, you are reading from the snapshot. And the scary thing is, it did work, even though I set the isolation level way after I did the transaction. So this is already beginning before I'm doing anything. So if you want to try, can I use snapshot? Quickly run this command, allow snapshot isolation on. If your server dies, no, you couldn't. But if it works, there will be no extra penalty if you use snapshot isolation. And the funny thing is, you can even, I'm going to copy this like that. You can even run transactions as the read committed is always using snapshot. This is Oracle mode. This read committed snapshot makes all the read committed snapshots read from the previous last known good version. So this makes SQL work just as Oracle does. So if you have somebody that says, oh no, we can't use Microsoft because Oracle is much better, just look at this. There's one command, and tempdb. But it works. So version store, yes, but in tempdb. I'm turning this off. Oh, stop transactions first. That's what you get when you copy, paste, and run things. Yes. So I have these demos I've pasted. They are in here also. So you've seen the snapshot demonstration, and you might wonder, how does it work? Well, let's go to the front row again. I hope you remember your numbers. It's easy. It's easy, 1. Because right now I'm telling you 528. Okay. 528. 528, but you're 1. Okay. Yes.
5. 2. 15.
529. You're now number 6.
Okay.
So my transaction started at 522.
I suppose I'm number 1.
He supposes he's number 1. Yes, that is because I started to read, I connected before he got his change. And actually, if it was supposed to be really correct, you would run and stand in the end of line. Because this is so fast. I'm reading all the values just up until the time when my transaction started. And that means nothing personal, but if I say that you must leave the room, you actually are sitting here and you send your friend to say number 10 is gone. So you can stay, but you must invite a friend to sit in the end of the line and say, don't count him if it's after 5:30. That's smart, huh? And that means that we can use the most efficient way of getting information. We are using the information from beginning until the end. And fragmentation? No. We have no fragmentation because we are reading things from the beginning, and then we have the changes that probably are in line out through the door because we have done a lot of changes in the beginning of the table. So we read from the beginning to the end. So, did Mikael just now said that we had no fragmentation? Yes, he did. And of course, he's wrong. Because we have fragmentation. Because when you move, you're moving according to the clustered index, so we still have fragmentation. And we also have the add-on of the change queue in TempDB. So we don't just have fragmentation. We have fragmentation and some kind of mathematical magic joining our database and TempDB and getting a smart result that is calculated by code that is written by even smarter people. That sounded slow, right? Yep. So I think we need to speed things up. Imagine this logical row of people, the first row, with changes adding up later and later and later. Imagine if you can take that into memory, into RAM. Just add it without fragmentation, without anything. Would we need blocking? Would we need locking at all? Why? We are always reading from the beginning to the end. Everything that is happening, inserts to the end, get a time and to the end. Updates, well, he stays. Updates to the end and get a time. Deletes to the end, get a time. So no, we don't need blocking. We're just scanning memory structures like it's supposed to be with snapshot isolation, but since they are using normal disk structures, we are still slightly crippled with locks. But this technology is lockless, basically. We're reading in the same direction, appending only. There is no edits, there is no in between or fragmenting things. That's what making it so fast. But not only, this is to be noted. You've seen this before? Update product in memory with snapshot. I have to tell it, oh, this is snapshot. And I have to tell it, get this one with snapshot. Oh, but it was snapshot, wasn't it? Yes, but the error says you are already in snapshot isolation. Remember? I ran the snapshot on the wrong database or the wrong connection. So I have to put this one like that and then run this transaction again. And now this one is updated. And of course, this one, again, before anything started, oh, memory optimized tables and natively compiled cannot be accessed when the session is set to snapshots. No, so I'm setting it to read committed and select star. Yes. Oh. From the beginning to the end, no order, because this order is in hash ordered in memory table. Makes no sense, so I need to just look at it the same way. You saw I copied the command? I pasted it, so I'm running it. And it works. This one is now not blocking anything. And I can even do this. I can do begin transaction and select star, like, no. And this is where it gets nasty. Because the things you saw before, the disk tables that has slightly fragmentation things, they are accessible. They work pretty much the same with snapshot isolation. But in memory tables, they work totally different. So you get different exceptions, you get different problems, and you must rewrite your code to use this really fast. And that means that my transaction is only working if I specify with snapshot as the query. And that means also that if I order by product ID, we can see again that I'm reading. But this is only because I'm doing begin transaction. If I don't do begin transaction, it works without or with a snapshot thing. Okay, because that's the same thing right now. Why is this so fast? You see, it's 0.000. It's so fast. It's running in memory. And memory is so much better. Again, yes, it's memory, but it's not actual buffer pool memory. It's internal structures. And that is why it's so fast. You remember the database name? Number? 5? So if I'm going into the data folder, into the extreme transaction processing folder for database 5, I have the DLL for the memory structure pointers that run inside SQL address space. So this is no longer 8K pages that get stored and gets somehow optimized or added to the buffer. This is a sequence or an array of structs. And if you don't trust me, we can do something like this and see the source code for this struct that is my in-memory table. And we have character short, some search key that is my index, and another short. And you can change this if you like, and then you will break SQL, I'm sure. So I wouldn't recommend it, but it's still open. You can see what it is. And the funny thing is that there's a way to make this faster, even faster. Because this one is running some kind of transact SQL to in-memory pointer emulation mode. So this one is transforming products in mem to some kind of query row set. And then it's converting it to 8K pages and viewing it, but much more efficient, of course. But the thing is that if we really want to make this go fast, and I'm going to do the rollback like that, and hopefully, yes, good. So hopefully I'm going to succeed doing this. Because you all know everything goes faster with store procedures, right? And this one, create procedure with native compilation. That is exactly what it sounds like. This Oh, star is not allowed in schema-bound objects. And I'm so lazy. So how do we do? I'm just looking at this one and write product ID. This is like the third time I forget do not write in code. Just saying. List price. Like that. Okay. Cannot schema bind because products in mem is invalid for schema. Names must be in two-part format. Oh, yeah. Update DBO dot products in memory. That's a best practice that is so hardly enforced in memory. Please. No. No. And since this took so much time and I had to rewrite my terrible hard query, this must be faster. Right? And it is. Because now I have gotten also, yes, I will get access to it soon enough. I have received an XTP procedure as well. And this is the C# code of the procedure that accesses the pointers to the in-memory objects and does the calculations as they should. And if somebody knows C, you will recognize that somewhere here there is some code that you will recognize. I was kind of unspecific here, right? So this is generated code. And this makes the accessing of in-memory tables so much faster because they go like we physically looked at, but they do it in memory and they access not 8K, but just exactly the amount of memory optimized that you need to calculate the delta or the remainder of what's in the table. In memory. Non-persistent. But again, the thing is here. That if I accidentally go into my database, where the database files are, of course, here. We see a structure. It's this one here. Is a very optimized binary structure that is called file stream storage. And that is written appended. Sounds familiar? It's only appending to the end. It's reading in a special order, and it's also pre-allocating to reduce fragmentation. This one is the reason that you can keep your data in the in-memory tables. Because when you restart SQL, it initiates the file system, it reads sequentially, and runs the in-memory data generation thing from beginning to end, and then your memory structure is available, your tables are available. But if you want to speed things up, you can make them schema only. That means you save the time it takes to save data, but if you reboot SQL, your tables are gone. No, sorry, the data is gone. The tables are still there, but the data is gone. So this would be a good thing for logs that you don't need to keep, but you need to have some kind of viewer that views and displays data in almost real time. This is the perfect thing for that. So, how could we keep ourselves from blocking other people? And how could we keep other people from blocking us with the problem? I have like 5 minutes left, right? Good. We can do shorter transactions. That means if I need to ask, oh, can you be number 28 instead of 10? It's better to ask before you start the transaction. Fix everything, check the user input, do the pre-work, then you do your transaction, do the stuff, and commit. Short transactions, keep locks for a shorter amount of time. You could go to snapshot isolation if you have the tempDB. If you have tempDB in SSD, that would be good. And if you want to go all in, do the in-memory thing. Because then you're not using locking on disk or in memory at all. You're doing latches, just reading swoosh really fast. That's the best. But of course, that demanded some coding, maybe even rewriting your procedures, recompiling all procedures, and as a side note, it's not so very good at combining in-memory tables and disk tables in joins. So you have a mix of normal SQL and in-memory SQL usually in the database. So when you anyway go all in to rewrite your procedures, your code, why don't rewrite the reports, as I joked about before in the beginning? Like, we can read from another table. Yeah, and everybody laughed. Oh, stupid idea. No, it's not. Availability groups, read-only replica, and do the big, heavy reading on that machine, and then you can do the transactions on your live server. That's a good thing. And when you're considering, okay, we might have 2 machines, why not go all in? Copy things to another database with a smarter structure, maybe even do a transactional BI thing on it, or go real BI to have an analysis services server, Power BI reporting, so you offload your transaction system totally. That is one solution to prevent blocking from other users. So I hope you have gotten several ideas about how to do this, and if you need to ask anything, I will be here, not removing my cable until I'm told I can do that. But feel free to come up here and ask questions, and otherwise, it is time for party. Thank you.